Hello students, welcome to Educate. In this video, we will discuss about the terminology or used in coordination compounds. Uh, Previously, we have discussed about the introduction of coordination compound, and we have also discussed about the difference between double salt and the coordination compound. Now let's see the terminology used in coordination compound. First one is coordination entity. So first of all, let's see here in coordination entity. Just briefly I am telling you. Here, this whole word, that means NICO whole form, this whole is coordination entity. Nickel here, that is central atom or ion, and here this carbon monoxide, that is the ligand, and whole this one NiCO whole 4 as a whole is coordination entity. In the same case, in this compound PtCl2NH3 whole twice, platinum is the central atom or ion, chloride ion is the ligand, ammonia molecule is ligand, and as a whole is coordination entity. Same here in another example, FeCN whole 6 4 minus. Here iron is central atom or central ion. Cn minus, cyanide ion, Cn minus is the ligand, and as a whole FeCN whole 6 4 minus, that is coordination entity. In the next example, CONH3 whole 6. Here cobalt is the central atom or ion, the ammonia molecule is ligand, and as a whole is coordination entity. So coordination entity is the central atom along with the molecules or ions surrounding them are collectively called coordination entity. The central atom along with the molecules or ions surrounding to them are collectively called coordination entity. So write that coordination entity is the metal atom along with the molecules or ions surrounding them. Then after is central atom or ion. So obviously here the metal atom around which the ligands or around which the molecules or ions surrounds is called central atom or ion. So ligands central atom or ion is the metal atom around which the molecules or ions are surrounded is called central atom or ion. Okay, central atom or ion is the metal atom around which the molecules or ions surrounds in a definite geometrical manner, that is called central atom or ion. So central atom, this one is As for example, let's see here. There is FeCN whole 6, 3 minus. 3 minus means here any cation has been bonded, in which total charge will be plus 3. So as for example, there is K3FeCN whole 6, this one. So here potassium is not the central atom or ion. Actually here iron is the central atom or ion, because the Cn minus is surrounding the iron. That's why iron here is the central atom or the ion or the central ion. Okay. Now ligands. So ligands is the molecules or ions which surrounds the central metal atom. That is called ligands. So very simple here. Ligands is no, this ligand is of two types. Here, unidentate ligand, types of ligands is unidentate ligand, didentate ligand, polydentate ligand, ambidentate ligand. This one. Unidentate ligand, didentate ligand, polydentate ligand, and one is ambidentate ligand. These are the types of ligands. What is unidentate ligand? Let's see here in Cl minus. Only one atom will surrounds this central atom. So in the Cl minus, there is only one donating site. Only here chlorine atom can donate the electron to the central atom. So only chlorine can do bond formation with central atom. That's why it is unidentate ligand. In the same way, OH minus. In case of OH minus, the negative charge is on oxygen. The extra electron is with oxygen. So here only oxygen can be bonded to the central atom. So that's why this one is also unidentate ligand. So these are unidentate ligand. But when you consider about Cn minus, in case of Cn minus, a structure is here in Cn minus, both carbon as well as the nitrogen contain the lone pair of electron. Here both carbon and nitrogen contain a pair of electron. So here carbon can be also bonded to the central atom, and with the carbon can also bonded to the central atom, and nitrogen can also be bonded to the central atom. But if carbon will be bonded to the central atom, then nitrogen will not bond. And if nitrogen will be bonded to the central atom, then carbon will not bond. So this will be called ambidentate ligand. Ambidentate ligand means which contain two donating site. The ligand which contain two donating site, but at an instant only one atom will donate the electron. So that will be called ambidentate ligand. Same here, SCN minus. It is called thiocyanato. SCN minus here. So in this case here, sulfur can also be bonded SCN minus. So sulfur can also bond to the central atom, and nitrogen can also be bound to central atom. So this one is ambidentate ligand. Why? When sulfur will be bonded to the central atom, then nitrogen will not bond. And if nitrogen will bond to the central atom, then sulfur will not bond. So SCN minus as well as Cn minus, these are the example of ambidentate ligand. Why? Here Cl minus and OH minus ion It is the example of unidentate ligand. Okay, so unidentate ligand, ambidentate ligand. In case of unidentate ligand, only one atom can do bond formation with central atom. But in case of ambidentate ligand, the two atoms can do bond formation with central metal atom, but at an instant, only one atom can do bond formation with central atom. Okay, so if you want to write, you may write that unidentate ligand, the ligand which contain only one donating site, that is called unidentate ligand. Ambidentate ligand, ligand which contain two donating site, but at an instant only one atom will donate the electron and hence do covalent bond formation with central atom. Okay, next one is here didentate ligand. As for example, I am taking here ethane 1,2-diamine, about which you will discuss, you will aware later on. Here ethane 1,2-diamine, this is a structure. In ethane 1,2-diamine, there is a lone pair of electron to the nitrogen atom and a lone pair of electron to this nitrogen atom also. So this nitrogen can also donate the electron to the central atom, and that nitrogen can also donate the electron to the central atom. So when both will come here, so there will be formation of a ring that will be called chelate ring. This ring is called chelate ring. Obviously, suppose this one, my hand. So suppose this hand here, when both will get joined, so there will be formation of a ring, and that ring will be called chelate ring. Initially, both is free. When both get bonded to a place, then there will be formation of a ring. That ring will be called chelate ring. So didentate ligand means the ligand of which the two atoms, will donate the electron to the central atom simultaneously and hence forms the chelate ring. That is called didentate ligand. Okay, didentate ligand means the ligand of which the two atoms donate the electron to the central atom simultaneously. That is called didentate ligand. So ethane 1,2-diamine is an example of didentate ligand. Okay. Oh, here it is given already. Oh, this is different. Okay. So same here, a polydentate ligand. About that we will discuss here. So polydentate ligand. What happened here? This one compound. Let's see about this compound. I am erasing this one so that comfortably you could watch this one. Of this ligand, ethylene diamine tetraacetate ion. This one is called ethylene. This one ethylene diamine. This acetate is 4 acetate there is, so tetraacetate. Ethylene diamine tetraacetate. This one, and here how much donating site? So let's see, nitrogen can donate the electron. This nitrogen can also donate the electron. Here, this acetate ion, that means through this oxygen, can donate the electron. This oxygen will also donate the electron. This oxygen, this oxygen. So total this ligand is containing 6 atoms which can donate their electron to the central atom. So these are called polydentate ligand. Polydentate ligand means the ligand of which a number of atoms can donate their electron to the central atom and hence can do covalent bond formation with central atom, the ligand of which a number of atoms could donate their electron to the central atom and hence can do covalent bond formation. So how much number of electron that's donated? That is here. That is polydentate ligand. Polydentate ligand. Then after here, and this one didentate ligand and this polydentate ligand. That is called chelate ligand. Chelate ligand includes didentate ligand as well as the polydentate ligand. Okay, ambidentate ligand. I hope this one clear. So that was about the ligand. What is the ligand? That was here. Then after is coordination number. Okay, coordination number, very important topic. Coordination number. What is that? Listen. Coordination number is the number of atoms which is bonded to the central atom covalently. The number of atoms bonded to the central atom covalently. That is called coordination number. So if a unidentate ligand here, unidentate ligand, in case of unidentate ligand, the coordination number will be, so number of unidentate ligand. If there be didentate ligand, so coordination number will be equal to 2 into, so coordination number will be equal to 2 into number of didentate ligands. Okay, and if there is polydentate ligand, so what is there? In case of if there be polydentate ligand, then n into n is here. How much denticity is there? So that may be also number of polydentate ligand into their denticity. Denticity means how much electron, how much atom will bond there covalently. Okay, so coordination number is the number of atoms doing bond formation with central atom. That is coordination number. Coordination number. So you may also equal to write that coordination number is equal to number of unidentate ligand plus 2 into number of didentate ligand plus number of polydentate ligand into their denticity. No need to mug up here. So obviously, if in the coordination compound there be only unidentate ligand, so their coordination number will be that much. How much? Unidentate ligand. If there be didentate ligand, so of didentate ligand, the two atoms will be bonded to the central atom simultaneously. So that's why the coordination number will be equal to 2 into number of didentate ligand. Same if they are polydentate ligand, like ethane monodiamine, like here, EDTA. So in this case, how much? That is, if suppose, which is not practically feasible, but even though, just hypothetically you consider. So if suppose here 2, number of EDTA is 2. So that will be 2 into 6. That will be coordination number. So coordination number is the number of atoms bonded to the central atom. That is called coordination number. That is I hope very simple here. Like suppose in this molecule here, COEN 3 whole thrice 3 plus. So its coordination number will be how much? 3 ethane is ethane monodiamine is there, and ethane monodiamine is a bidentate ligand. So that's why 3 here and bidentate ligand. So 2. So here coordination number of in this compound. This 3 due to this one. 3 is due to this one, because 3 number of ethane 1,2-diamine is 3 and denticity of ethane 1,2-diamine is 2. So that's why coordination number will be 3 into 2, that is 6. Same here in this molecule, same 3, and here oxalate ion is a bidentate ligand. The structure of oxalate ion is like this. So this oxalate ion contain two donating site, this oxygen and this oxygen, two donating site. So here density, here it's a didated ligand, so its coordination number will be 2 into number of didated ligand is 3, so that's why 6. Okay, that is here. And this one is very easy, nothing, no need to bother about that. Very easy question these are. Then after this, coordination sphere. Same here, the central atom along with ligands which represented in a square bracket, that is called coordination sphere. Like this one is a coordination sphere. Okay, coordination polyhedron, what is that? So coordination polyhedron is analogous to that of shape of molecule. Like we tell the shape of molecule the methane is tetrahedral, but here in case of coordination compound, the coordination polyhedron will be tetrahedral, octahedral, and like that. So here the coordination polyhedron can be defined as the arrangement of ligands around the central atom in three-dimensional space. Coordination polyhedron, this one is example, you know here tetrahedral, octahedral, asphalt planar, and so on. That is coordination polyhedron. Okay, oxidation number of central atom, and which keep there here this point carefully. Oxidation number, what is that? This one is very important. What is oxidation number? Let's suppose here in this molecule, if we remove all the molecules from here, then how much charge will appear? That will called coordination oxidation number of central atom. Here let's see. Three minus is here. Suppose 4 Cn minus you remove from there. So 4 unit of positive charge will appear on the copper. When you remove all the 4 Cn minus, then 4 unit positive charge will appear on the copper due to the removal of this one Cn minus. So 4 unit positive charge, and there is already minus 3 positive negative charge. There is minus 3 charge already, and if you remove the Cn minus from the central atom copper, then total charge will be here plus 1. So oxidation number of copper here will be plus 1. Here you can also find out x plus 4 into minus 1, that equal to minus 3. So x equal to plus 1. So oxidation number is the charge appears on central atom when all the ligands is supposed to be removed from the central atom. Okay, oxidation number is the charge appears on the central atom when all the ligands is supposed to be removed from the central atom. That is called oxidation number. That means here Okay. Next one is very easy. Homoleptic complex and heteroleptic complex. As about the term homo, a number of times you have studied homo. So, homoleptic means the complex compound in which only one type of ligand will be present. Like if ammonia is a ligand present in the compound, then if in the compound there be only ammonia, then that will be called homoleptic complex. And if there will be two or more types of ligands present in the compound, coordination compound, then that coordination compound will be called heteroleptic complex. Like this one here, CONH3 whole 6 3 plus, this compound. So here only one ligand, that is ammonia, is present. So that is called homoleptic complex. Here in this compound, here only one type of complex, only one type of ligand is present. That's why it is homoleptic complex. And in this compound, here there is two types of ligand present. Two types means two different ligands. Like ammonia and chloride, there is two different ligands is present. So it is called heteroleptic complex. So this one is heteroleptic complex, this one is homoleptic complex. So in case of homoleptic complex, what is that? Homoleptic complex? So that is complex in which only one type of ligand is present. This is homoleptic complex. Same heteroleptic complex. That's you write by yourself. When complex in which more than two types of ligands are present, that will be called heteroleptic complex. And the example will be this one. Heteroleptic complex means complex in which two or more than two types of ligands are present. That is called heteroleptic complex. Example, this one. This was the terminology you should know, but very important topic of this chapter is nomenclature. Here, and paramagnetic behavior also, you know, the magnetic behavior of the compound, that's also frequently asked in the NEET examination as well as in IIT main examination. Nomenclature and magnetic behavior, that is the two portion which frequently asked in 12th board examination in addition to IIT main and NEET examination, and there is also high probability of asking this question in CUET examination. So about the nomenclature we will discuss in the next class. It's all for this class. Thank you, Team Educate.